Prevent waste. Green chemistry focuses on reducing or eliminating waste from the start, rather than managing it after production. This designing chemical processes that minimize byproducts and pollution. In nanotechnology, this process is applied by developing greener materials and processes that avoid waste generation at this source. For example, scientists create nanomaterials using more efficient reaction that leaves little to no harmful residues. Use safer solvent. Many chemicals processes require solvents, which can be toxic or hazardous. The goal is to replace them with safer alternatives or avoid them entirely in nanotechnology. This means choosing water-based or biodegradable solvent instead of harsh chemicals that harm both humans and the environment. By using a bottom-up strategy, researchers build nanomaterials in ways that eliminate the need for harmful solvent, making processes more sustainable, increasing energy efficiency. Energy-intensive chemical reactions contribute to environmental damage. Green chemistry promotes conducting reaction at room temperature and pressure whenever possible, reducing energy consumption. In nanotechnology, this means developing energy-efficient synthesis methods, such as catalysis that lower reaction temperature, or utilizing renewable energy sources. This approach not only saves resources but reduces the overall carbon footprint of nanomaterial products. Production.
Productions Production of harmless chemicals in the second principle of green chemistry. The designing of enzymes in chemical processes and products that lowers toxins into humans and the environment. Applying this concept to nanotechnology for safer human nature and still effective for their intended use. Nanotechnology deals with materials at an extremely small scale. Scientists achieve this by using safer elements. Instead of toxic heavy metals, scientists coat nanoparticles to reduce harmful interactions with cells or ecosystem. This this is important for reducing health risks, prevent environmental conditions, and to support sustainable innovation.
A less hazardous chemical refers to a substance designed to minimize toxicity and adverse environmental impact while maintaining its effectiveness. This chemical follows the principle of green chemistry by reducing risk to human health and ecosystems.
Use renewable feedstock means using sustainable and eco-friendly raw materials in industrial processes. Whenever possible, renewable resources like crops, wood chips, and processed waste should be used instead of non-renewable ones like fossil fuel and mined ores, which are limited and depleted.
In green chemistry, utilizing catalysis means designing and using catalysts to speed up chemical reactions while reducing waste, energy consumption, and environmental impact. Catalysts enable reactions to occur more efficiently and selectively, often under milder conditions which minimize hazardous byproducts. Catalytic processes are preferred because they can be used in smaller amounts and regenerated, which are consumed in the reaction. Some benefits are lower energy demand, higher selectivity, reduced toxicity, sustainable and renewable process. Avoiding chemical derivative aligns with one of the principles of green chemistry. This principle encourages minimizing unnecessary chemical modifications that can lead to waste and require additional reagents, solvents, or energy. Why avoid chemical derivative? Well, derivatives create a waste and require additional reagents. They also use extra energy and can generate hazardous substances.
The seventh principle of green chemistry: maximize atom economy. This principle focuses on designing chemical reactions using all or most of the atoms, starting materials in the final product. Instead of having to create waste, the goal of this is to design chemical reactions to minimize byproducts, to make the process more efficiently and sustainable. Nanotechnology involves creating materials at the molecular or atomic scale by using fewer raw metals, by reducing the general of byproducts and waste, and making processes more efficient. The way scientists achieve this is by choosing efficient reactions using chemical reactions that incorporate most of the raw materials into a final product. Basically, this means recycling the atoms. The importance of this is to reduce waste and pollution, while also making the product more sustainable. For the 10th principle, designing chemicals and products for degradation. This principle creates chemicals and materials that break down naturally into harmless substances, and instead of persisting in the environment causing pollution, these materials should decompose safely, being harmless. In nanotechnology, many materials like plastic and synthetic chemicals last for decades and harm the ecosystem. Although nanotechnology focuses on designing materials that biodegrade into non-toxic substances and breaks down under natural conditions, also does not accumulate in living organisms and does not harm the environment. Scientists achieve this by using biodegradable materials, creating non-particles from natural substances like plant-based polymers and so on. An example of this is by scientists are developing drugs delivery nanoparticles that dissolve safely in the body. The importance of this is that it reduces long-term pollution, prevents toxic buildup in the nature, supports sustainable and eco-friendly environment in innovation.
Real-time analysis for pollution prevention involve continuously monitoring and control pollution levels to detect changes instantly to minimize the generation of hazardous substances. This allows immediate action to reduce pollution and protect the environment, like tracking air quality in a city. It is always better to prevent waste than to clean it after it's created. Minimizing the potential for accidents means choosing reagents that reduce the risk of explosions, fires, and toxic releases, ensuring safer chemical processes.